Okay, I thought it might be helpful to take a review, guys, about something that is going to help us with graphing in the third case. We have just worked with the case 1 and case 2 in rational expression, right? In this class, we're going to see what is the third case about. Before going into that, guys, do you remember? I'm going to ask you something. Do you remember how to graph a linear function? Okay, Mr. What is a linear function? Okay, a linear function is, guys, something like this. Let me see. A function which the greatest degree, guys, for x is to the first power, something like this, x plus 5. Do you remember how to graph that, guys? Okay, we can use a table, guys, and take different values, the same, right? But let me tell you that there is another way easier to graph this. Okay, instead of using table and giving different values, guys, there is another way that I really love, and I'm pretty sure you're gonna love it too. Okay, you don't need to copy this, just pay close attention to this. Okay, how do we graph that, guys? Okay, there is a way called a slope intercept form. Okay, a slope intercept form, and we're gonna use this idea, guys, to graph these linear functions. And what is the slope, guys? Okay, you have the function, this is the standard form, you have the function y equals to a number with the variable x plus another number. Okay, this, guys, this number, the coefficient for the variable x is called the slope. Okay, and what is the slope? Perhaps you don't remember exactly, but the slope, guys, is the ratio of the coordinate y and coordinate x. What is that? Y over x. I'm going to explain you that with details. And b is the y-intercept. I repeat, if you have a linear function like this coefficients for a variable x is the slope, and the constant term is called the y-intercept. You remember this, right? You remember that always this number alone is the y-intercept, even in the quadratic form. Can someone tell me, given this function, what is the slope for this, guys? What is the slope?
1.
X, but is the exactly, okay, the coefficient for that is 1. Excellent, 1. And what is the y-intercept for this function?
Positive 5.
Positive 5. Excellent, just that. Okay. But I'm gonna try to work on that. Mister, what does this y over x means? I'm gonna explain you that. Let's try to graph this. Okay, let's keep that on mind. Okay, let's suppose you don't need to copy this. Pay close attention to this. Let's say that we are asked to graph this function y over 3 over 2x plus 1. Guys, using a table, yes, you're gonna follow it because we can use just 2 points, right? Because it's gonna be a line, a straight line. But it's gonna take you a lot of time. Take a look at this, guys, and how are we gonna graph that? 3 over 2x plus 1. Okay, let's identify the information, guys. That is the first thing that we're gonna do. What is the slope? M.
3/2.
Okay, slope is the coefficient in the variable x. Okay, 3/2. What is the y-intercept?
1.
Okay, positive 1. Well, it's positive only the 1. Excellent. This is the only information, guys, that I need to graph this. Now, let's see what I'm gonna do. Can someone tell me, can I represent the y-intercept, guys? What is the y-intercept? What is the y-intercept?
Horizontal way.
Okay, the y-intercept is the point where the graph is going to cross the y-axis, right? Okay, what is y1? Okay, y0, y negative 1. No, it's positive 1, y1. Okay, in these points, guys, I'm gonna have the point, the graph. I know that the graph is going to cross right here in this point. Okay, guys, and how many points do I need? Because I know this is going to be a straight line, guys. How many points do I need in order to graph a linear function or in order to make a line? I have
3, 4.
3, yes, 4, but at least, what is the least amount of number that I need? 2. If I have another here, I make the line. Okay, that's why, guys, using this is gonna help us. Okay, and how I'm gonna get the next point? Pretty simple, by looking at the slope. The slope is telling you, guys, the inclination of the graph. Okay. And do you remember here that I mentioned that the slope is a fraction, y over x. Okay, let's put that here. Y, this stands for y and this stands for x. Okay, what does this mean, guys? You have the first point and you're going to move according to this slope. Okay, how many units do you have to move in Y?
3.
When it is positive, guys, do we move up or down? When it is positive in Y? Up, right? It's going to be up because it's positive. Okay, let's move 3 units. Okay, 1 from this point, from the Y-intercept. 1, 2, 3. Okay, 3. And how many units do we have to move in X?
2.
2. In X, we always move to the right. 1 and 2. Okay, we got the second point. Okay, let me make the second point again. And do I need another point to make this line? I don't need it at all. Okay, with this point, guys, I can make this line. Okay, and this is the linear function. Mister, I would have used the table instead. Perhaps we haven't gotten familiar with this concept, but this is how we do it, guys. Take a look that I only got my information and I do it. I don't need to make a table when it is a linear function. Mister, I didn't get it. I know perhaps you don't get it at the first example. That's why we're gonna try to solve another one. You don't have to copy this. Let's see. This is a linear function. Okay, the highest degree is 1. Okay, let's identify my information. The information, guys, that I'm gonna need is the slope, and I'm also gonna need the y-intercept. The y-intercept. Okay. Y-intercept, guys, is where the graph crosses one of the axes. In this case, the y-axis. Okay, you got it right. It's 3, right? Is this value? It's 3. And what is the slope for this function?
-2.
-2. Thank you. Excellent. -2. This value, guys. But the slope is a fraction always because it's y over x.
1.
Okay,
Over 1. Down.
exactly. Okay, this -2, I only add a 1 in the denominator. Okay, I'm going to repeat, guys. These numerators is the movement, is the change in y, and the denominator is the change in
X.
Look, guys, that now we're getting familiar with this. Is going to be easy. Y-intercept. Okay, let's look for y3, y1, y2, and y3. Exactly here. Okay, I'm going to make my point here. Okay, y3. Okay, that is not 3 actually. Okay, this is 3. Okay, this is y equals to 3. This is where the graph is going to cross. And now the slope, guys, okay, from this point, I need to move. This is going to be my starting point. I'm going to move 2 units negative. Okay, that means down. Excellent. Okay, 1 unit down, 2 units down. Excellent. Okay, and how many units next?
1.
Okay, just 1. Okay, and here, guys, here, okay, is going to be my next point. I repeat, this is my first point, the y-intercept. Let's move -2 down. Okay, -2 means down. 1, 2, and 1 to the right. Okay, in x, in the x direction. Okay, here's going to be my next point. And with this information, guys, it's good enough to make my graph. Okay, and this is my function. What is this function? Y, oh, well, -2x plus 3. Is it easy, guys?
Yeah.
Let's take a look at the last example. Okay, the information, guys. That's the first thing that I need to get out of this. Okay, M and y-intercept. What is the slope for this function?
-1 over 1.
But I need a fraction. Sure. Okay, I'm gonna add a 1. Okay, what is my y-intercept? What is this number, guys? I got
0.
Oh, excellent. It's 0. That's it. It's 0. I repeat, this is y and this is x. Okay, let's do it. Y-intercept equals 0. Okay, y-intercept is y equals 0. Okay, it's in the center, right? Okay, it's right here. Okay, and now let's move according to this slope. Okay, in order to get the second point. Okay.
-1.
Negative
Down.
means 1 unit down, and how many units to the right in x?
1.
1. Okay, here. Okay, and we're gonna get my second point. And now, guys, let's make the line. Okay, that's awful, but let's suppose that it's a straight line. Okay, this line is y equals to -x. Okay, this is the function. You remember, guys, how to divide polynomials using the long division? Okay, if you don't remember, do not worry. I'm gonna explain you how to do it. Okay, let's say that we have x squared plus 2x plus 1 divided by x plus 4. Okay, how can I divide this? Using the long division. We also have the synthetic division too, right? Do you remember? But we're gonna use the long division. Okay, first of all, okay, let's rewrite this, guys. I'm gonna use a different color here. Am I recording? Yes, right. Okay, I'm going to rewrite this x squared plus 2x plus 1. Okay, divided by x plus 4. Okay, guys. How can we divide? Can someone remind me? Do you have an idea how to do that? Do you remember?
You can work separately with the
Mhm.
x and 4.
Okay, yeah, that's it. The idea is this times how many times can I put this inside of this? Okay, it is a little bit tricky. What we do, guys, is we take this, the greatest one, and we divide it by this. Okay, separately, as you told me, x squared over x. And what is that equals to, guys?
X.
To the first power, right? 2 minus 1 is x1. Okay, let's put it here, x. Okay, this is my quotient. Okay, now what I need to do, guys, do you remember that? It's like the same division, normal division. Multiply this times this, right? Okay, let's do it. X times x.
X squared.
Let's put it x squared. Okay, I'm gonna use a different color here. Okay, it's x squared. And this one, x times 4, guys.
For x.
Okay, that's it. All of them are positive, right? But do you remember that we subtract? Okay, after multiplying, we subtract. We find the difference. Okay, what are we gonna do, guys? All of them were positive. Let's see. All this was positive actually. This was positive. Okay, this was positive too, right? Okay, but what we do, guys, because we have a negative, do you remember that all of this is minus, right? But I don't want to do that, guys. Okay, what I'm gonna do, guys, I'm going to change the sign, right? That's the idea. Okay, instead of positive, guys, all of them
Negative.
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 Okay, that's it. That is the idea. Okay, negative, negative. Okay, now let's simplify. It's better. X squared minus x squared, guys.
0.
Okay, this is 0. Okay. And 2x minus 4x.
Negative 2x.
2x. Okay, negative 2x.
Plus 1.
To get the next term down. Okay, plus 1. Again, guys, this divided by this is the same idea. Okay, we're gonna take the greatest value here, 2x, over the same, this one, x. What I get out of this, guys?
2.
X's can be canceled. I just get 2. Okay, plus 2. Positive, right? Positive. The same idea, guys. This multiplying this. 2 multiplying x, 2.
2x.
That is 2x. Positive, right?
Mister, if we divide negative
Yes.
2x divided by x, it's not gonna be
Yeah.
negative 2.
I ate off the
It
negative.
has to be negative
Yes,
2.
yes, you're right. You're right. Excellent. It's negative 2. Okay, it's negative 2. Thank you. Thank you. What a huge mistake. What was going to do? Okay, let me raise that. It's negative. You're right. I completely agree with you. It's negative. Thank you. Okay, you notice that on time. Okay, negative, negative, negative. Okay, 2 times x is going to be negative 2x, right? Let's put it negative 2x. Negative 2 times 4. Negative 2 times 4, guys.
Negative 8.
Is negative 8. Okay. Okay. Over, but mister, I remember that we have to subtract, right? That is what we do with the division. Okay, but instead of having this negative, guys, what I do is I use the distributive property and I change. I know that this is gonna change, right? Okay, what I do, guys, I only change the sign. This is negative. It's gonna turn it into positive. This is negative.
Positive.
Positive. Okay, that's the idea. Instead of having that, a lot of things there. Okay, let's subtract this. 2x plus 2x minus 2x plus
0.
This is the key, guys. If I, with this mistake, guys, I would have noticed here because I couldn't cancel. That's the idea. 1 plus 8.
9.
9.
This is the remainder, right?
Yes.
All of that.
Remainder.
Idea, guys. Okay, welcome to today's class. What I want to try to explain, guys, is how to graph fractional functions. But we have different cases, right? Today we're going to get on board with the case 3. Okay, this is going to be the 3.1 because we have a tiny difference with, even though that, like, I'm going to explain that later. Okay, what is the case 3 about, guys? The case 3, guys, is when you have the degree of the top, I mean the degree of the numerator, is greater for 1 unit, okay, that's why, for 1 unit, than the degree of the denominator. What do you mean with that? Let me explain you that. Let's put an example here. Y is equals to 2x squared, for example, plus 1 over x. Okay, take a look that in this case, guys, the degree of the top, okay, here is greater, right? This is a square, and this is your first power. Okay, but what is the difference between these degrees, guys? This degree, notice, of the top is greater just for 1 unit, okay? Because this is 2 and this is 1. Okay, this is the kind of function, guys, that we're gonna graph. When this degree of the top is greater, but just for 1 unit than the denominator. Okay, what is if it is greater more than 1 unit? Okay, that is gonna be the case 3.2. Okay, let us focus on this. Okay, some information, guys, that I need you to know. What is the horizontal asymptote? Okay, I don't know. What is the vertical asymptote? The vertical asymptote, guys, is, as you notice, has never changed. Okay, we said the denominator equals to 0, right? Even if it is the first case, the second case, the third case, it's gonna be the same. Okay, the vertical asymptote is the undefined values in my domain. Okay, we only said the denominator equals 0, and that's it. That is never gonna change. Okay, what is the thing that is changed, guys? That always change according to the case. Is the horizontal asymptote, right?
Horizontal.
Yeah, did this change according to, in the first case is one thing, in the second case is another, and in this case it's gonna be another thing. Okay, let me tell you, what about the horizontal asymptote? Guys?
When it's in the first case, is the number that is.
In the first case, yeah.
But in the second, you have to divide.
Is the number, and the second is the ratio of the top leading coefficient and over the degree, over the coefficient of the denominator, and it's different, right? In this case, guys, we're not gonna have a horizontal asymptote. In this case, 3.1, we're not gonna have a horizontal asymptote. Okay, and what are we gonna have then? Therefore, there will be an oblique. Okay, I'm missing something here. Okay, there will be an oblique or slant asymptote. What is an oblique and slant asymptote? I'm gonna explain you what is that. I haven't told you what is an oblique or slant asymptote. Okay, this is an asymptote, guys, that is neither vertical nor horizontal. So what is that? This is the vertical. Okay, this is a vertical asymptote. This is a horizontal asymptote. Okay, an oblique is neither this nor this horizontal. Okay, it's gonna be something with an inclination. Okay, it's something like this. It could be something like this too. Okay, this is an oblique or a slant line asymptote, especially. Okay, let's try to graph this. Okay, we're gonna try to graph this, guys. Okay, according to the, this is case 1, guys. Okay, can someone tell me case 1, case 2, or
Case 3.
case 3.1? We call it
3.1.
Okay, why? Because the degree of the numerator is greater for 1 unit than the denominator. This is 2 and this is 1. The difference between them is just 1. Okay, case 3.1. Okay, let's find, guys, the vertical asymptote. Okay, how do we find the vertical asymptote? This never changes, guys. It's exactly the same for all the cases. What is the vertical asymptote?
The denominator is 0.
X plus 4 equals 0.
X plus 4 equals
X equals
0.
negative 4.
X equals negative 4.
Thank you, Angie. Thank you, Sarah. Excellent. That's it. Really simple. These guys, I love the vertical asymptote because it never changes. It's exactly the same. Okay, we only said the denominator equals to 0. Now, the horizontal asymptote. What did I tell you about the horizontal asymptote?
None.
We don't have, right?
None. We don't have it.
We don't have horizontal asymptote, but we have a what? An oblique,
An oblique asymptote.
oblique or slant asymptote. And oh my gosh, what is that, guys? Okay, in order to do that, guys, okay, I'm gonna call this oblique asymptote. Okay, oblique asymptote. Okay, and what is the oblique asymptote, guys? The oblique asymptote, you can find it like this. Guys, if you try to factor this, do you think you can factor this and cancel something with this? Because we have to take a look at that. We have to take a look at that.
No,
Okay, we can factor this
we can factor, but we can cancel.
X plus 1 times X plus 1, right? But X plus 1 is not equals to X plus 4.
Yes.
Cancel. You have to take that into account, guys. We always try to factor. But in this case, even though we have a trinomial here, if you try to factor, you will not able to simplify. Okay, guys, when you cannot simplify, you have to take that always into account. What are you going to do, guys? You're going to divide this using the long division. Okay, you're going to divide x squared plus 2x plus 1 all over what?
X over.
X plus 4.
Okay, in the case number 3, I repeat it. If you cannot cancel, most of the cases you're not gonna be able to cancel this. You're going to divide this. Okay, you're going to divide this. Okay, let's divide this, guys. If we try to divide all of that, guys, what are we gonna get? Do you remember? I haven't done it in the
X minus.
okay. I haven't done it in the video, guys. I'm not gonna do it because of the time. Okay, what is the answer? What is the quotient? X
Minus.
x minus 2. Okay, guys, this value, guys, is your what? Oblique asymptote. This value, guys, the quotient here is gonna be your, okay, is x minus 2. X minus 2 is gonna be your oblique asymptote. But I need something here. Okay, what is that, guy? Y. You can put f of x, but we say y. Okay, this is the information that we need. I repeat, the vertical asymptote, you only set the denominators equals 0. You solve. We don't have a horizontal asymptote. We have an oblique or a slant asymptote. How do we find it, guys? Dividing this using the long division. Numerator divided by denominator. Okay, this divided by this. And this quotient, guys, is going to be your slant asymptote. Okay, guys, let's move on to the graph. Okay, this is the most important thing. Okay, what I'm gonna try to do, guys, is I'm going to represent my horizontal and vertical asymptotes. Okay, can someone help me? What is my, oh my gosh, 3 minutes. Okay, what is my
Vertical asymptote.
okay, -4. Okay, 0, -1, -2, -3, -4. Vertical asymptote. Okay, I'm going to represent that. Okay, this. X equals to -4. And what about my, we don't have horizontal asymptote, but we have a slant or an oblique asymptote. This is my,
An oblique asymptote.
these, guys. And how do we graph this, mister? I don't know how to graph it. Yes, you know, I just taught you. Okay, this, guys, is a linear function, right? X minus 2, the first power. What information do we need? M and Y-intercept. What is the slope in this case, guys? What is this value?
1 over 1.
1 over 1.
Thank you, 1 over 1. And what is my Y-intercept?
-2.
Next 2.
Guys, you're amazing. Okay, you're amazing. Okay, let's plot that. Okay, let's plot that. Y-intercept is -2. Okay, this value. Okay, let's make the point here, -2. And now let's move according to this slope. 1 unit down. Okay, 1 unit down. And how many units to the right? 1. Okay, 1, 1, right?
1.
This numerator stands for the Y and the denominator for the X movement. Okay, 1 units up and 1 units to the right in X. Okay, guys, with these 2 points, we can make the line easily. Okay, let us make the line.
But that line's gonna be dashed, right?
Yes, because it's an asymptote that is just gonna be approaching. Okay, this. Okay, and now I'm gonna erase that as you told me. I'm gonna erase that. Okay, I'm gonna make it dash. Okay, because it's just a horizontal asymptote. Okay, I'm gonna make it dash. Okay, guys, do we have time? Oh my gosh. Oh my gosh. Okay. Okay, this is what we got, guys. Okay, now guys, what we're gonna do, we're gonna take two values to the right of that vertical asymptote, always in the table is the same, and two values to the left of that. Okay, and let's see what we're gonna get. Okay, let's make the table.
-6, -5, -3, -2.
Okay, let me see the time, guys, and I will not be able to take these values. Okay, what I'm gonna do in the next class, we're gonna try to solve. But now, guys, it's up to you. This is gonna be your classwork. Take two values to the right, that is, which is -3, -2, and take two values to the left, which is -5 and -6. Guys, I'm not sure about this Slant asymptote. I don't know why. But
With the original Mister in the middle is gonna be the original graph, or no?
The original function, right, mister?
have something like this. We're gonna have something like this, and in
Yes, it's gonna be
like this.
Mister,
Tell me.
Mister,
Yes, yes, I hear you.
Mister, I didn't understand.
We're gonna do it in the next class. No problem. Okay, but try to do something. Okay, try to plug in the table, and we're gonna see what happens. Don't worry. In the next class, we're gonna go into that again with more details. It's because of the time. Bye, guys.